Highland Vallis Ranch is approximately 9,000 acres, 14 square miles, or 36.4 square kilometers, being 4,400 deeded acres, with an additional 4,600 acres leased from private and BLM lands. It is located within the famed Front Range of the Colorado Rocky Mountains. It is southwest of Colorado Springs, and the local Gold Belt Tour Highway runs through the ranch. At an average elevation of 7,500 feet, or 2,286 meters, the elevation ranges from 7,100 feet at the mouth of High Creek on the east side of the ranch to a high of 8,600 feet in the mountains on the west end. Valles is the Latin spelling of valley, thus Highland Vallis is the valley in the mountains. This valley is formed primarily by the weathering of Migmatite rock outcrops. The ranch is located very near the divide between the Platte and Arkansas River basins, with over 5 miles of High Creek stream valley running through the ranch. This divide, including Pikes Peak, acts to condense moisture, notably Gulf of Mexico moisture originating from the southeast, which typically protects the ranch from the worst snowstorms, yet allows ample and consistent moisture for forage growth and water supplies. As a result, this general area is referred to as a banana belt, meaning it is a bit warmer and less snowfall than the surrounding higher elevations. High Creek is a predominantly subterranean stream running through the granitic gravels with intermittent surface flows. The tested sparkling clean water originates from the summer rains and winter and spring snowfalls. Outcropping rock formations are 2-billion-year-old migmatites with 30-million-year-old ignimbrites and tuffs deposited unconformably. The two combining to form excellent and unique high CEC sandy loam to loamy soils. Highland Vallis is located 30 miles southwest of Colorado Springs, an hour's drive going through Manitou Springs, Woodland Park, and Florescent Fossil Beds National Monument on the way to the ranch. Wildlife include, but certainly not limited to, elk, mule deer, bighorn sheep, bear, mountain lions, lynx, bobcats, coyotes and turkey. The cattle on the ranch were started from the family herd in Texas and moved to Highland Vallis. Vegetation areas includes a mix of forested grassy slopes, blue grama grass meadows, and meandering perennial and wet weather stream valleys with occasional springs or seeps. The nearest community is Cripple Creek, where gold mining and gambling are still the primary sources of income. Commercial flights are from Denver and Colorado Springs. Colorado Springs has many local attractions including the following: the world-renowned Broadmoor Hotel, Garden of the Gods, Broadmoor World Arena, World Figure Skating Hall of Fame, U.S. Olympic Training Center, U.S. Air Force Academy, Cheyenne Mountain Zoo, Glen Erie Castle, Bishop Castle, Pro Rodeo Hall of Fame, Will Rogers Shrine of the Sun, Seven Falls, Helen Hunt Falls and the Western Museum of Mining and Industry. Other nearby attractions include the Florescent Fossil Beds, Royal Gorge, Cripple Creek Gold Mines and Casinos, Pikes Peak Railroad, abundant rafting, biking, hiking, skiing, horseback riding and climbing adventures. Breckenridge, Vail, and Denver are about 75 miles away in a northerly direction and take an average of about 2 hours to drive going through the mountains. The Royal Gorge and Arkansas River are less than 30 minutes to the south. The quality and chemistry of the water, soils, and forage at Highland Vallis are exceptional. The climate is driven by both Pacific and Gulf of Mexico moisture being lifted and condensing over the mountains, forming rain in the summer and snow in the winter and spring. Below is a discussion of these and other elements of the science of Highland Vallis. Topics include 1. Migmatites, 2. A very long unconformity, 3. Plate tectonics, Farallon and Shatsky, 4. Mountains, minerals, rifts and volcanoes, 5. Highland Vallis soils, 6. Highland Vallis forage, and 7. Highland Vallis water. Migmatites. The oldest outcropping rocks on the ranch are called migmatites. They are a transition phase between a metamorphosed sedimentary rock, mostly a metamorphosed mudstone, and an igneous rock, mostly a granite. This rock began as a shale, then was metamorphosed into slate, schist, gneiss, then partially melts into an interbedded igneous granite. The following discussion will shed light on the formation of these oldest rocks at Highland Vallis. Geologic processes do lots of things, one of which is to sort and segregate materials. For example, under windy dry conditions, coarser sand materials are left behind to form sand dunes while the finer materials are blown away to a distant location. The materials are sorted and separated according to their density and aerodynamics. Similarly, but different, in plate tectonics, more dense basalt rocks which make up ocean basin floors tend to be subducted down and under, and the less dense granitic rocks tend to float upwards. These lighter, less dense granites then amalgamate and make up our continents. Our existing North American continent is actually an amalgamation of older, smaller continents. This diagram from Wikipedia Wyoming Craton gives a simplified insight as to the geologic complications of the formation of our existing continent. Essentially, each area is its own microcontinent in the formation of the existing North American plate. As these smaller microcontinents are drifting together in the formation of the larger continent, basins are forming and materials are being shed from the smaller continents into the basins to form sedimentary rocks, like shales, for example. The Highland Vallis story begins about 2 to 2.5 billion years ago, which is about halfway through the age of the Earth. These smaller previously formed granitic microcontinents are drifting together and shedding material into the existing basins. This is the origin of the Highland Vallis Migmatite materials and some of the oldest rocks on the continent. The chemistry of these rocks suggests that they were originally a kaolinitic mudstone. Kaolinite typically forms from the breakdown of minerals in a hot humid environment, a tropical environment. The following XRD analysis gives the mineral assemblages of the shalier schistose end of the migmatite consisting of quartz, kaolinite, and microcline, a sandy mudstone, with some potassium feldspars. Other results include muscovite and biotite, the latter of which usually results in vermiculite, an excellent soil-forming clay. In the following billion years and more, these original sedimentary rocks, mostly mudstones, are buried and begin the transition from sedimentary rocks through metamorphosed rocks eventually to melted granitic rocks. The following diagram helps to understand this process from shale, mudstone clays to migmatite. This image is that of an actual migmatite on Highland Vallis. This is one with a particularly thick igneous seam about 1 foot thick within the schistose, or unmelted material. To be fractal is to be similar as scale is changed. In other words, what is seen on the small scale is also seen on the large scale and vice versa. There is a fractal-like appearance to these older migmatite rock formations. An alternating igneous metamorphic, or migmatite, trend is seen in the large-scale outcrops that is similar to the small-scale individual rocks. It is unclear whether these are alternating melts, dikes, faults or something else. This fracture trend is north-south, seen across the ranch and probably contributes to the topographic low and namesake of the ranch. In this image, a migmatite band is flanked on either side by a granite. Within this granite is a xenolith, or inclusion of the migmatite within the granite. This suggests that the granite was once the migmatite, and that is has completely melted into the granite, that is, all but the xenolith. However, there could be alternate explanations. A very long unconformity. Imagine your retired Uncle Albert is going to pull a family album together. He gathers all of the family photos and history from 1850 forward. Uncle Albert likes a cocktail and cigar in the evenings. One evening he drifts off to sleep after spending the day working on the family album. The lit cigar falls out of his hand and onto the stack of old newspapers, catching all on fire. Poor Uncle Albert and all of the family information is gone, everything is lost in the fire. The above image reflects the human vision of a geologic unconformity. It is not that things didn't happen, it's just that we lost the direct record of them. We still know much. We would know the family went through the Civil War, World War I, Roaring Twenties, Depression, World War II, Korean conflict, Vietnam War, and on and on. Unfortunately, the photo of great-granddad in a World War I uniform is now lost forever. At Highland Vallis, there is an unconformity from approximately 2 billion years ago to approximately 35 million years ago. A lot happened during this time, truly a lot, but those rocks that represent this time period are now missing. There are two things to remember regarding this unconformity. First, things did happen, we just don't have a record of them at this particular location, and second, because the rocks are gone, the missing rocks are not having an impact going forward. That is, the missing rocks are not having an impact on such things as current soil development or grass or forest growth. As a result, we will let most of this time go without discussion, but it is an important fact to keep in mind. Plate tectonics, mountain building, Farallon and Shatsky. In the interval starting about 160 million years ago, in the previously mentioned unconformity, and in a plate tectonic sense, North America began drifting westward, away from Africa and Europe. Simultaneously, located west of North America, in the Pacific, was another plate called the Farallon Plate. This continental plate was drifting eastward. Associated with this plate were probably island arcs, think of Alaska's Aleutian Islands, and possibly an island referred to as the conjugate Shatska Rise. Shatsky may have been an island much like Iceland is today. Iceland is splitting down the middle, one half going east, towards Europe, the other half is moving west. If Shatsky existed and did something similar, the west half is now over close to Japan and the east half slid underneath North America. Also, this Farallon plate with all of its complications, did not simply dive off into the deeper part of the Earth's mantle immediately, as many plates do, but in fact, hung in shallower and for a longer distance. What this means is, North America has had a pretty bumpy and long ride over the Farallon plate. This has allowed the mountain ranges to form far inland from the initial subduction zone. The illustrations are to help you to visualize this event of Western North America sliding over this older Farallon plate. Generally, this process is divided geologically between two orogenies, mountain building periods, the Sevier and the Laramide. Note the double subduction of the Farallon plate, which is supported by actual seismic data. Mountains, minerals, rifts and volcanoes. With the background provided in the previous sections about the North American plate sliding west over the east drifting Farallon plate with its rough topography, we are now better able to understand the mountains, volcanoes, pyroclastic flows and mineral development of Colorado and Highland Vallis relationship within this area. First, think about the mountains. Think about an entire continental plate sliding underneath our own plate. There are 3 episodes, 2 primary mountain building episodes and a basin-forming episode. The Sevier orogeny and the Laramide orogeny are compressional events, and the Rio Grande Rift is an extensional or tensional event. The Sevier orogeny is really the precursor to Colorado mountain building. Think more of this event affecting Utah and the age range of 160 to 50 million years ago. But, to understand the complete history, you should begin by being aware of this beginning orogeny. Next is the primary Colorado mountain building orogeny, the Laramide. Compared to Sevier, the Laramide is further east, in Colorado, and younger or 80 to 30 million years ago. So, the Sevier-Laramide orogenies together is more of a west to east progression of mountain building, as our continent drifted west over the Farallon plate. Finally, after this progression of compressional forces, we begin to change to extensional forces and the continent begins to pull apart or stretch. An excellent human-scale example of this is a chiropractor's traction machine. It lifts and stretches the back. A similar thing happens within a continental plate, lifting, relaxing and releasing pressure. A decrease in pressure within the continent, and especially a magma chamber under or within a continental plate, can facilitate the formation of gases within the magma. This is not unlike a shaken-up Coke bottle with the lid coming off. The result is explosive volcanoes with tuffs and ignimbrite rock formations being formed. A tuff formation is the rocks formed from an ashfall of a volcano, and an ignimbrite, is what is formed from a pyroclastic flow coming down and spreading out from the volcano. The opening illustration of this section is for a visual. Also associated with the tensional or extensional situation, the Earth expands and gravity pulls down, forming basins, such as the Tularosa Basin with White Sands National Monument in New Mexico, or the Alamosa Basin in Colorado, and possibly the Yampa Valley of northern Colorado. This is an illustration to help with visualization of the timing of these events. The different arrows give an indication of the relationship and lengths in millions of years of the events. Use this illustration by looking from the bottom up. Rifting is the uplift and separation, or extension of a continent. It results in tensional forces and basins, or topographic lows. This may seem counterintuitive to have an uplift or rise result in apparent lower topography, but mathematically a certain amount of land is being spread over a larger area. The basins fall into the extra space created. Typically, this forms from a linear heat source from the deeper parts of the Earth, the mantle. Two very important aspects of rifting are 1. A deep-seated heat source, and 2. The distance between the heat source and the surface is less than average. This causes shallow heating, which heats and moves fluids and allows for magma formation. The shallowness allows for a decrease in pressure on the magma, resulting in gaseous volcanoes, and the fractures formed with the rifting allow for conduits for fluid and magma movement, forming both volcanoes and magmatic dikes. The primary linear Colorado mineral belt has produced in the range of 25 million troy ounces of gold among other minerals, and likely started in the Precambrian, and may be associated with the original formation of the basin that produced the Migmatites at Highland Vallis. The linear nature of the trend suggests a possible fracture or suture between two microcontinents, then reactivation may have occurred during the severe orogeny and the Laramide orogeny. Finally, during activation of the Rio Grande rifting and volcanics, we had magma and fluids moving up and along the fracture zone. This would likely result in the emplacement of the minerals. The Colorado mineral belt is conventionally described as a northeast to southwest trend, but there are also other deposits in Colorado that could be inferred to promote a secondary trend, an arc trend that ties the ends of the linear belt. The Cripple Creek volcanic-related gold deposit is away from the linear trend and on this arc trend. It appears to be fracture-related hydrothermal deposition after volcanic. The diagrams of Cripple Creek indicate a carbonate sedimentary country rock area, meaning sedimentary rocks prior to the volcanics. However, most of the regional maps indicate the country rocks are Migmatites, being the same found at Highland Vallis. Perhaps the Cripple Creek country rocks are a different lithofacies of the Migmatites found at Highland Vallis. Possibly it is more of a shelf carbonate than the deeper shale kaolinite. Notice the metamorphosed turbidites on the flank of the main feature on the following diagram. This would be associated with shale clastics. So, the gold, besides being in the throat of the Cripple Creek volcano, seems to be hydrothermal, low to medium temperature, and associated with the faults and fractures. At Highland Vallis there are tuffs and ignimbrite outcrops formed from volcanics scattered across the ranch. They are the uneroded remnants of several layers formed from the volcanoes of the area. These are likely interbedded between Cripple Creek-associated volcanics and 39-mile volcanics, which are principally located to the north and west. The 39-mile volcanics are the same group of volcanics associated with the burial and preservation of trees at Fluorescent Fossil Beds National Monument located north of Highland Vallis. The chemistry of the volcanics is variant from intermediate, andesitic, to felsic or rhyolitic, meaning a good combination and mix of elements. This photo is of a beautiful felsic ignimbrite outcrop with abundant cristobalite and sarnadine. A nearby and probably associated volcanic outcrop, Rocky Point sample, has a much higher sarnadine plus vermiculite is seen, which would greatly increase the quality of the soils that derive from these rocks. Although not a lot of vermiculite in this sample, it does give a window into the decomposition of these rock formations. Highland Vallis soils. The previously discussed Migmatite and ignimbrite rock formations are eroding to form excellent soil horizons. With a mostly black appearance, the Highland Vallis soils appear to be predominantly clay, but that is not the case. After doing many soils tests, the general texture of the soils are about 2/3 sand size, 1/5 silt size, and 1/8 clay size. Remember, sand is an unusual word in that it has two meanings, one is a size and the other is the chemistry. To be clear, presently, sand refers to the size of the particles, not the chemistry of the grains. Because the surrounding mountains are being eroded into the soils are very coarse-grained and hence 2/3 sand size. As these materials move downslope, the overall grain sizes should continue to reduce. The soils are coarse because they are near to the source of the material, the migmatites and ignimbrites. Generally, these soils are classified as sandy loams. Soil chemistry suggests the soils are typically about 1/3 sand in a chemical sense, meaning 1/3 silica dioxide, SiO2. The other 2/3 of the soils are a mix of 1. Feldspars, potassium, calcium and some minor sodium, 2. Micas, muscovite and biotite, and 3. Clays, kaolinite, illite and vermiculite. As the soils are developing, it appears the biotite is converting to vermiculite, the best clay, first. The muscovite is likely transforming into illite, but there is not a lot of direct evidence of that. The kaolinite, which is the most degraded and least effective clay, is probably a remnant of the original 2 billion-year-old sedimentary basin. Perhaps the kaolinite formed from the decomposition of the feldspars in the original microcontinents. Cation exchange capacity, CEC, is a soil's ability to hold natural fertilizers like potassium and nitrogen. Higher CEC has higher fertility. Typically, CEC increases in clay soils and decreases in sandy soils. The unique quality of the Highland Vallis soils is that it has the CEC and fertility of a clay soil, but the infiltration and fluid mobility of a sandier soil. With increasing mobility of fluids in the soils, there is also increasing mobility of the ions. The following image indicates some changes in soil chemistry in a vertical section. In summary, the soils tend to have the good chemistry of a mixed clay, but with the infiltration rate of a sandy loam. This means the ranch is a precipitation sponge, minimizing erosionary runoff with good soil chemistry. Highland Vallis forage. There are 3 different areas of forages. 1. Steep forested slopes. These have good grass, but have not yet been tested. 2. Alluvial intermediate slopes or meadows. And 3. Creek bottoms. Due to the slightly increased water availability, the creek bottoms have more vegetation volume, with a slightly lower protein content, approximately 12.5% protein, while the meadows have slightly lower vegetation content, but a higher protein content in the range of 14.5% protein. Highland Vallis water. Water quantity. The primary water source on the ranch is High Creek, a subterranean and surface flow stream which provides ample water for the ranch and more. As previously discussed under soils, the soils materials at Highland Vallis are coarse materials close to the bedrock source material. This sandy material allows for most water to migrate underground. Also, an important part of the water flow physics is the stream gradient. As water moves above the ground surface, there is no impediment or resistance to stream flow, therefore the water can run off faster with the higher mountain gradient. This idea is further magnified by a plant called the desert willow. The root system of this plant further slows the downstream movement of the water. You can think of it something like an underground beaver dam. Water quality. Water quality is excellent. The following 3 water tests are from High Creek, West, East Central, and East samples. All 3 of these samples are better quality water than Lubbock, Texas city water by comparison. Primary constituents of the very clean water are calcium, carbonates or bicarbonates, and some minor sulfates. Thank you for learning about Highland Vallis Ranch. If interested in purchasing our 100% natural all grass-fed beef or conducting any testing at your home or property, please contact us directly at 325-473-4400 during normal business hours. That's 325 473 4400.